Hi everyone. Today we are going to discuss here problem number 4 based on powers of complex number. So let me start here. The complex number is a very easy topic. So complex number can be written as any complex number can be written as z is equal to x plus iy. Any complex number can be written as z is equal to iy, and we have to find its power. So here, if x plus 1 by x is equal to 2 cos theta, y plus 1 by y is equal to 2 cos phi, z plus 1 by z is equal to 2 cos psi. That notation is psi. Okay, that notation theta, second one is phi, and third one is cos psi. So these are three different cosine angles are there. Then prove that, number one, we have to prove that xyz plus 1 upon xyz is equal to 2 cos theta plus phi plus psi. These are the angles. Okay, means 2 cosine of the angle theta plus phi plus psi. We have to prove the first. Number second, we have to prove here x raised to m divided by y raised to n plus y raised to n divided by x raised to m, it is equal to 2 cos m theta minus n phi. Number third, x raised to m y raised to n plus x raised to, means this is written as 1 upon x raised to m y raised to n is equal to 2 cos m theta plus n pi. Okay, so this is what this is given example. Okay, and we have to solve by using powers of complex number. Means there is a related theorem is there is a de Moivre's theorem. There is a de Moivre's theorem. So let me write first. We have Euler's formula, guys. Okay, we have e to the power I theta can be written as, or this may be, it is a plus or minus I theta, can be written as, this is a cos theta plus or minus I sin theta. So that result is called as Euler's formula. Okay, Euler's formula. Okay, also and we have also cos theta plus I sin theta bracket power n can be written as, this is cos n theta plus I sin n theta. So we called, this is a de Moivre's theorem. Okay, so we called in short form, that is a de Moivre's theorem. Okay, so for references, give the equation number 1 and give the equation number 2 for that. Okay, now what is a given? So given here, given x y z, guys. Okay, what is a given? X y z means x plus 1 by x is equal to 2 cos x. Okay, I am writing here, therefore x plus 1 by x is equal to 2 cos x. Can I write now this in this way? This is x plus x inverse, that is equal to, this is 2 cos x. So this is nothing but there is a 2 cos theta. Okay, so you have to given here, there is a 2 cos theta is there. Okay, also x plus x inverse can be written as, this is again 2 cos theta, means 1 by x, we can write x inverse is there, and comparing we have to getting that, therefore I have write again x plus x inverse, this can be written as, this is a e to the power I theta plus e to the power minus I theta, we can write instead of 2 cos theta. So what is the reference here? So reference is, that cos theta, that is circular function, it is e to the power I theta plus e to the power minus I theta divided by what? 2 is there, divided by 2. So we call that is a circular function is there, guys. Means comparing what we'll get. So therefore here we have to already getting x plus x inverse, so this is equal to this is equal to e to the power I theta plus e to the power minus I theta. So comparing we get what is that here? X is equal to e to the power I theta. X is equal to here e to the power I theta. Okay, this is equation number 3, guys. Here this is equation number 3. So similarly here y plus 1 by y is, we have to given 2 cos phi, 2 cos phi. So therefore this can be written as, this is y plus y inverse, that is equal to 2 cos phi, and 2 cos phi can be written as, it is e to the power I phi, it is e to the power I phi plus e to the power minus I phi. Okay, so therefore I am comparing here again. So what you will get, y is equal to e to the power I into phi. Also z plus 1 by z, for the reference we call, this is equation number 4. This is given to you, that is a 2 cos psi is there. Okay, so therefore this is a z plus z inverse. This can be written as, it is e to the power I psi plus e to the power minus I into psi. So again here comparing, what you will get here, z is equal to e to the power minus I into what, y is there. So this will becomes plus I into y is there. So for references we call, this is equation number 5. This is equation number 5, right? Okay, so using these 3, 4 and 5, you have to taking, or you have to solve the first. Okay, so here proof of first. Okay, so how to prove this first? Let's see. This is very easy, because you have to given the first is, what is that? Now I am writing here now to prove number 1. What is that here? That is xyz plus 1 upon xyz is equal to 2 cos theta plus phi plus psi is there. We have to prove. So taking LHS, therefore LHS is equal to, LHS is xyz plus 1 upon xyz is there. Okay, now I can write x value is e to the power, from equation number 3 and 4 and 5, e to the power I theta. This is e to the power plus I phi, and into e to the power I into psi plus 1 divided by here again e to the power I theta into e to the power I phi into e to the power I into psi. This is from equation number 2, 3 and 4. Okay, means I am writing here, since from equation 3, 4 and 5. Okay, we have to write out this. Okay, after again simplifying, it will get e to the power I theta plus e to the power, so there is multiplication is there, therefore this base is the same, guys. This base is the same, right? So this is e to the power I in bracket, that is a phi plus theta plus psi is there, plus 1 upon e to the power I into, again here theta plus phi plus psi is there. Okay, so this can be written as, this is e to the power. Okay, this can be written as, in the next step, this is e to the power I into phi plus theta plus psi is there, into this denominator term taking in numerator as, it is e to the power minus I, that is again theta plus phi plus psi is there. Okay, so in this way there is a plus, is a sign is there. Now here base is the same. Now here base is the same, so by using again Euler's formula for circular function, so therefore this is equal to, this is a 2 into cos of, that is a theta plus phi plus psi is there. 2 into cosine of theta plus phi plus psi. So what is the result by using here? So this is x y z, means here LHS is equal to, so LHS is equal to, what will get here? LHS is equal to 2 cos theta plus phi plus psi, and you check this is equal to RHS, and you check this is equal to RHS. Okay, so this step by using the reference formula is here. Since cos theta is a to the power I theta plus a to the power minus I theta divided by 2 is there, guys. Okay, means that becomes 2 cos theta, it becomes e to the power I theta plus e to the power minus I theta. Okay, hence first proved, hence first, that is number 1 proved is there, is proved. Okay, so after proving the first, we have to prove the next. Let's see. Also, number 2, to prove number 2, what is we have to prove? X raised to m upon y raised to n plus y raised to n upon x raised to m is equal to 2 cos m theta minus n phi is there, guys. Okay, and therefore I am writing here LHS, guys. I am writing here LHS. So LHS is equal to, here is x raised to m upon y raised to n plus y raised to n upon x raised to m. So therefore this can be written as x raised to m, it is nothing but, you know the value of x raised to m. X raised to m means here e to the power I theta bracket power m divided by e to the power I phi bracket power n plus, here is again e to the power I phi bracket power n divided by e to the power I theta bracket power m. That is simply like, this is a, what is that? This is a x raised to m upon y raised to n plus e to the power I phi raised to n divided by I theta bracket power m. Okay, now this can be written as, this is e to the power I theta means bracket power m means it is e to the power I m theta into, if you take denominator in numerator, that is e to the power I n phi plus e to the power I n phi into e to the power, now this will get a minus is there, minus I m theta. We adjust denominator in numerator. Okay, guys. Okay, so therefore that will equal to, we have to getting the next term as, this is a base is the same, so indices addition, e to the power I is a common here, so this is m theta minus n phi. Okay, and that is what, this is a indices property, by using indices properties there. Okay, plus e to the power I in bracket, that is again m theta minus n phi is there. Okay, means I into m theta minus n phi is there. I am taking minus sign here common, and said therefore by using result, so what is LHS? So this is nothing but it is a 2 cos of m theta minus n phi. So here LHS is equal to what? RHS, and hence the proof. Okay, so I think I hope you this, all of you getting this example. Now next we have to also prove the next and third part. Okay, so number 3, to prove, what is we have to prove? Number third, this is x raised to m plus y raised to n, means here number third, x raised to m y raised to n plus 1 upon x raised to m y raised to n, and that will equal to, this is 2 cos of m theta plus n phi is there. 2 cos of m theta plus n phi. So we're taking again LHS. Again LHS. LHS is again I'm writing x raised to m y raised to n plus x raised to m y raised to n is total bracket power what? Minus 1 I'm taking here. Okay. So this will get, this can be written as LHS is equal to, this is e to the power theta bracket power m, it will becomes e to the power I m theta, also it will becomes I n phi, right, and plus taking bracket, in bracket is there, so e to the power again here I m theta into e to the power I n phi, and it's a bracket power minus 1. Because of that, this is a reciprocal of this term. This is a reciprocal of this term. Now I am taking here LHS as, this is I is a common here, so this is e raised to I into, that is m theta plus n phi is there, plus e to the power here I is common out here, so it is again means minus I is a common is there, so this is m theta plus n theta, guys, m theta plus n theta. So this is m theta plus n phi is there. Okay, so taking minus sign as a common in powers of or indices of e. Okay, that is a base is a e is there, guys. Okay, and by using again, so using again the formula is what? The formula is cos theta is nothing but this is e to the power I theta plus e to the power minus I theta divided by 2. We have to getting the LHS as it is a 2 cos of 2 into cos of, that is m theta plus n phi is there. Okay, and therefore I am writing here that LHS is equal to, you see what is RHS, so LHS is equal to RHS, and hence the proof, hence the proof, guys. Okay, so I hope you all of you understanding this example. So let me revise just once again. So you have to given this problem, there is x plus 1 by x, we have to given this problem, there is x plus 1 by x equal to 2 cos theta, y plus 1 by y is equal to 2 cos phi, z plus 1 by z is equal to 2 cos psi. Then we have to prove that xyz plus 1 upon xyz is equal to 2 cos theta plus phi plus psi. Number second, x raised to m upon y raised to n plus y raised to n upon x raised to m. This is a 2 cos m theta minus n theta. Number third, plus x raised to m y raised to n plus 1 upon x raised to m y raised to n is equal to 2 cos m theta plus n phi is there. We have to find out its a solution, means we have to prove all these three proofs is there. Okay, so you know the Euler's formula is e to the power I theta, that is cos theta plus I sin theta. Also you know that de Moivre's theorem, cos theta plus I sin theta bracket power n can be written as cos n theta plus I sin n theta. Now given to you x plus 1 by x is a 2 cos theta, and 2 cos theta, there is a substitution e to the power I theta plus e to the power minus I theta, that will becomes x is equal to e to the power I theta. Similarly we have to getting y is equal to e to the power I phi, and similarly we have to getting z is equal to e to the power I psi. Now we have to prove the first. So for proving first, you have to take just LHS, putting the value of xyz in this equation. To prove first, take LHS. LHS is xyz plus 1 upon xyz, putting the value of xyz in LHS. So by using indices rules, you have to getting again e to the power I in bracket phi plus theta plus psi plus e to the power minus I in bracket theta plus phi plus psi. So this is nothing but this is a cos theta plus, means phi plus psi is there, means that will also given as by using again circular function cos theta plus e to the power I theta plus e to the power minus I theta divided by 2. Okay, So you have to observe this, what is LHS and what is LHS. So number one is proved is there. So LHS is equal to RHS. Okay. Number second, you have to just same thing do is here. So take LHS x power m y power n plus y power n upon x power m. So substitute value of x y and it's a power, and you have to show here LHS is a 2 cos n theta minus n theta. So LHS equal to RHS, that you will get. The proof is there, guys. Okay, and number third you have to show is here x raised to m y power n plus 1 upon x raised to m y power m. This is a 2 cos n theta plus n phi. So take LHS, substitute the value of x y and its a power, use indices rule, and again use the circular function formula. You have to getting LHS is a 2 cos of m theta plus n phi. So LHS equal to RHS is there, and hence the proof. I hope you enjoy and understand this problem. Thank you.